I'm Mike Hinsley. I've done 32 years in IT, believe it or not, in many sort of like respects. I've got background in electronics and engineering before I got into IT, and then I've been working in corporate IT for quite some time in enterprise IT, including hypervisors and SaaS. Been using Apache CloudStack now for sort of 2 years plus, I suppose. In the middle of all of that, I got into working with aquaculture and apiculture. Apiculture is to do with bees and keeping bees. So I've sort of found the fact that I can leverage Apache CloudStack from a research point of view. So I can actually focus my research on what I want to do with aquaculture and apiculture, as opposed to where I'm spending my money on how I do it. And I've been hyperscaling and autoscaling bees for 6 months. And found a very useful approach with Apache CloudStack for that, I hope. So, what's the next one? Do it that way then. So I've got a combination of Apache CloudStack, open source technologies. I'm using Sonic and I'm using EVNG Pro, if you're familiar with that. That allows you to build like network simulation labs. So if you've used things like GNS3 and stuff like that in the past, I've taken a slightly different approach with that and coupling things together. From a storage point of view, I'm using Petasan, which is sort of primarily based on Ceph, and you've got overlays over the top that can do S3, NFS, SMB, etc., which are quite useful for what I'm doing. So the main three components for me is the apiculture research, aquaponic research. Aquaponics, if you've never heard of that before, that's basically growing vegetables with fish with no soil, which I'll explain a little bit later. And with my technology background, I found an opportunity to bring in IoT to this, which is where Apache CloudStack helps, especially with the edge technology that it's got. And I'm using some advanced networking to achieve that I'll explain as I go along. So this is where it gets a bit more interesting, in my opinion, from an engineer's point of view. So I'm leveraging Apache CloudStack basically as my framework to underpin everything I do. So it allows me to focus on what I want to do. So I am actually using Ampa's CPU technology and NVIDIA GPUs. That component at the moment is bare metal, but I'm looking forward to Apache CloudStack 4.2.1 and then getting into 4.2.2, so I can take even more advantage of getting better sort of like return on my investment, shall we say, from a research point of view, rather than it just being a bare metal box part to the side. Then on top of that, if any of you have played around lately with like AI, there's a tool called NA10, which again is open source and you can automate things. So I've bolted that into my technology. Where I've got the Ampere running and the GPUs, I'm running local AI, because I want to basically work to fine-tune my models to work. So again, this is where the whole hypervisor system and being able to use my GPUs, I'd like to be able to do more than one in parallel at the same time to get efficiency. So working towards that. I've got some rather interesting IoT stuff going on with lots of monitoring for things. So I'm monitoring things with the bees, for example, around sort of like audio frequency. There's certain things that happen with bees, and a lot of it's all controlled around the audio frequency of what they do in the hive. Then with the aquaponics, I've got stuff where I'm monitoring like water temperature, oxygen density, all of these sort of things. And all of this enables me to do this without interfering with everything all of the time. Whereas normally you'd have to constantly interfere with your bees at certain times of the year on a very regular basis, which can also have a negative impact. I can do all of this effectively remotely with technology now, and Apache CloudStack helps me do that. And I'm running Petasan for my storage solution at the moment because it's Ceph basically with some number of overlays on the top, and it also works quite nicely with Apache CloudStack. I'm doing some advanced stuff with networking, some of it in the traditional way with like static routing, dynamic routing, so I'm using BGP, VPN, but I'm also using LoRa technology, which is lightweight, long distance radio, and again it's to do with the bees, and you don't necessarily have a wireless network where your bees are, and you don't necessarily have a power source with a power cable where your bees are because they're out in the middle of nowhere. So again, bringing all of this stuff together. Apache CloudStack gives me the vehicle and the framework to bolt all of that together in a rather nice way. So I'm doing a lot of things for figuring out my networks and testing my networks and simulations for my networks. It gives me the ability to prototype things and test things without interfering with the things that I'm running in real time. So now effectively I've got the ability to have like test environment, production environment, go and do my testing before I do my releasing. I can also do simulations. And obviously it gives me all of this capability now, so I've got a lot of flexibility. I've got scalability if I need it, because when you're keeping bees, for example, you might have more than one apiary. It gives you advantages of manipulating bees. So I've now got an ecosystem that I can expand out across multiple apiaries. I can bring that back into a core system. I can run this because of the nature of what we do with the aquaponics. We also run off-grid technology. So we've got like 90 kilowatt hours of batteries, for example, 32 kilowatt hours of solar. So I've got the ability of like N+1 power. And I've got my own cooling systems with where I've integrated them with the ecosystem, with all of the water I've got in the aquaponics. I can take advantage of that. And again, I've now got the ability to manage all of my costs. I've got, you know, it's much easier to build a transparent system that other people can understand, so I'm not engineering something that's not easy. You know, I want other people to be able to use this, basically. And so, again, it's important to have a community that's working and sharing knowledge with people, being open with people, helping each other. And obviously sometimes in the corporate world and the enterprise world, you don't always have that opportunity. And then obviously it's very flexible and very customizable, as you'll see as we go through the slides. It's not rigid and fixed to only one way of being able to utilize the technology. And then obviously this means I can actually focus on my research now. So when you come to bees, whether anybody's familiar with looking after bees or anything like that, the challenge is really like, how do you monitor something that effectively is happening inside a box? And it's not that easy to see inside that box, and there's some key things that happen, like if the weight of that box is wrong at the wrong time of year, you can end up losing your bees. And most people are familiar with like wild bees and stuff like that, but when you start looking after bees, you start to realize the value of them, and you start to understand they're quite critical to an even bigger ecosystem for pollinating plants and things, but they're also quite expensive. And to look after them and maintain them at optimum can be quite challenging because it's in a box. So now I can take this technology and I can look inside that box in a real-time basis, in the middle of nowhere with no power cables, no network cables, and feed all of this information now back into a system, whereas I want to scale that system or add different sensors and different IoT technology. I've got the framework to enable me to do it. So that now gives me a solution. And that solution also allows me to collect all of that data, so I can process that data, so I can start to look at trends on that system. I can also look at trends. If you have like multiple apiaries, you normally keep them 3 miles apart, for example. So I'm not just looking at something happening in one box in one location. I can look on a much wider scale, and I can even scale it even larger than that now. So it's got the potential for other people to use the same framework. They could collect it and people could share their knowledge and their data, which could actually help them and help other people. So in the middle of all of that, I've got virtualization, which allows me to scale it. And in my scenario, I don't have tens of thousands of servers. You'll see I have the ability to run small clusters, very low power clusters. So everything's very efficient. I get very good return on value for my money. But at the same time, because of the technology that's underpinning it with Apache CloudStack, I can scale it. And I can do it very effectively and very quickly. Whereas other systems, if you tried to do this, like say 10 years ago, yes, there was hypervisor technology, but you're working with traditional networking, for example, traditional storage, lots of limitations. You're pinned to a particular CPU vendor, for example, and a lot of that technology needs a lot of cooling and a lot of power 9 times out of 10. Well, all of that has pivoted in the last 5 to 10 years, and it's only going to get more and more as time goes on. So that's where I've basically got all of these benefits now. But fundamentally, I'm able to have all of these benefits and use all of this diverse technology because ultimately of the hypervisor ecosystem and the orchestration framework that sits underneath it. So in regards to bees, it's like I can collect lots of things. I can put cameras inside literally the frames of the hives, so I can collect video data in real time. I can listen to audio sounds that are happening within the hives, because bees do a lot of things. They cool the hive down, they warm the hive up. There's certain ways they communicate, and most of it's basically either with pheromones or with sound. And there's different IoT sensors you can get for pheromones, there's different IoT sensors you can get for sound. And again, I can feed that into a system now that I can start to monitor. And not only can I just monitor it, but I can also apply AI to it. And again, I can do it within reasonable cost and reasonable budget and be very flexible. If something's not quite working, I can change it quite easily, readapt it, evolve it. So I've got a lot of flexibility now. And obviously with that, I need like centralized gateways. I've got data processing. I can build visualization now. Again, I can focus on my research. I can focus on that data. It gives me the ability to share that data with other people quite easily. And then with the aquaponics, that's like another ecosystem in itself now. So aquaponics is basically, you have fish, you have water, you have plants, and it's a recirculating system. And there are a couple of nutrient deficiencies you have to add, but pretty much it takes care of itself and looks after itself if you are able to monitor it and you're able to manage it. And the challenge a lot of people have when you start to scale those systems, it can get more complicated. So then you start splitting it into multiple systems. Well, now you need to track all of those multiple systems. So again, this is where IoT comes in, specialist sensors come in. But now you can introduce AI, for example, to track the data on those samples. Use like cameras, for example, to look at plants and see if there's nutrient deficiencies on plants. You can then monitor, for example, the oxygen level. So now you can start controlling the heating system or the cooling system on your water, or increase the oxygen level in your water automatically with workflows and automation tools. Again, using like IoT technologies, because it's a bit of a rugged environment. It's not a nice data center. There's lots of water around. There's sort of high temperatures because you do all of this in greenhouses. So you need rugged technology that can scale and communicate, and some of it you sort of keep a little bit further away and some of it you need quite close. So again, having something like Apache CloudStack gives me that framework to pull all of those core components together. That's where the advanced networking comes in. That's where having the ability to build scalable storage to track all of this data that you're collecting, because you're not just collecting it for a week or a month. You have a full life cycle pattern every year, and the same with your bees. And what you had last year is not necessarily the same as this year. So you need to be able to collect all of this, and again, focus on that as so much as trying to run your data center. And then obviously if you can achieve that, you've basically built another ecosystem which is sustainable, and you can control the environment and you can control the quality. So to build that ecosystem, that's where you've got your physical setup, which in principle, if you tear it back, is quite simple. You've got grow beds for your plants, you've got fish tanks and filters for your fish, you've got water pumps, you've got air pumps. But as you scale it, you don't have 2 grow beds anymore. You might have 20 grow beds. You might have different types of fish. You might need different filters, and there's different requirements for different plants, for example. So all of that data needs to be tracked and managed if you're going to get sort of like optimal as opposed to sort of failure, shall we say. And some of these things can be very subtle. So you might look at something day to day physically, but you don't spot it. The same with like something might be happening with the fish. Well, they're in water. You're not going to stick your head in the tank with the fish with the water to see what's going on, but you might put a camera in there. And so now again, you can use visualization to track how those fish are moving in that water. Are they doing what they're doing normally, or has something really changed? Have they stopped moving in that water? Have they stopped taking up their food? It helps you build all of this stuff, so now you can build monitoring systems and early warning systems to be more sort of like proactive as opposed to reactive. And again, automation plays a key part in that. IoT plays a part in that. So does scalability. But you also need something you can secure now, because ultimately everything you're building is transmitting across a network somewhere, and that network is going outside of your network. So having a framework that you can make things, you can have like separate VPCs, for example. You can have separate virtual firewalls. Now you haven't got to buy expensive equipment and rack it and stack it every time you want to go and build something else, especially as you scale these systems or separate these systems to make them more controllable and manageable. And this is where sort of like you end up with more complex networks and more scalable networks. Even on something you think, oh, well, it's quite small, I might have 300 sensors, for example. And you think, well, you've got a big greenhouse, but you've got 300 sensors. Why do you need 300 sensors? Well, I need to monitor so many different things, and they might be linked to different systems. So now this is where traditional VLANs are not necessarily as flexible, having to program normal physical switches as opposed to having software-defined networking. But you can automate it, you can script it, but this is much more flexible. And then, as you'll see a bit later on, I have other challenges, like I've explained. Not all of my stuff has a power socket at the end of it. Not everything has got a network cable at the end of it. Some of it's literally 3 miles away in a field in the middle of nowhere. And that's where the long-range low power comes in. And the low power across everything, for me, is quite key. And the flexibility to use sort of like cost-effective components that I can replace without destroying the rest of the system at the same time, and I don't have to reboot everything and start it all back up again and lose all of my data. So it might sound a little bit crazy using things like SDN and BGP and VXLAN for what I'm doing and LoRa, but once you start to understand the ecosystems and how these ecosystems come together, you start to realize how this stuff is very useful. But then it's having a vehicle that you can apply easily, as opposed to spending 90% of your time trying to manage this and only 10% doing your research and monitoring and managing your systems. So this is where all the building blocks come together then, even at the networking level, and having the ability to bring SDN and, more importantly, do simulations. So you can bare metal tools like EVNG, but you can also run it in KVM. And obviously you can run KVM inside Apache CloudStack. So now you can have multiple simulations and you can integrate into the VPCs and the networks and the virtual firewalls, all of this capability. So actually there's quite a lot of technology going on, but that technology ultimately enables you to look after your fish better, look after your bees better, look after your plants better, have better results, and consistent results that you can then share with other people and help them achieve the same sort of systems and things. Even if they don't build it to the scale that you do, there's consistency for them to look at. So ultimately then, all of that overlaps. And that is effectively your ecosystem, which gives you your research vehicle. And you don't necessarily have to apply this research vehicle to bees and plants and fish. It's a research ecosystem in its own right. And fundamentally, I could try and do all of that without Apache CloudStack, and I'm sure I could try and do it without any hypervisor, and I'm sure I could try and do it with other hypervisor technologies. But then how difficult does it become to manage, and at what point does it become unmanageable? And now everything you were trying to work for fails. So that's to me why finding Apache CloudStack and using Apache CloudStack is what's ultimately made the difference and enabled me to do what I do. Part of that is a storage solution. I'm using Petastan as a storage solution. I've worked with Petastan for about 8 years now. Personally, I think it's a very flexible solution. So it doesn't just give you Ceph. It gives you Ceph. It gives you a manageable way to manage Ceph. It also gives you overlays like iSCSI, gives you overlays with NFS, and you've got S3, and there's a lot of stuff now that I can start to do, so I can write my data into S3. I can protect my data, which means I can protect it from ransomware. And obviously these things You know, whether I've got £20 million or £1,000, ultimately my data is still important to me. And losing my data is a big problem for me because it takes a long time to collect that data. But I'm collecting it in real time, so I'm collecting a lot of data. So I need to be able to scale. And that's basically what Petasang gives me. And it works really well with Apache CloudStack. So that's a bonus. So you can see Apache CloudStack comes in, and obviously I'm not just running virtual machines. Again, because of Apache CloudStack, I can spin up Kubernetes clusters, so now I can have containerized things which are very lightweight. I can deploy them on CPU technology that's not necessarily AMD, it's not necessarily x86. I can use ARM technology as well. I can use very powerful ARM technology, I can use very lightweight ARM technology. I'm not pinned into a corner. I've got a lot of flexibility. And again, I've got a nice ecosystem to do it with, that it doesn't take me 6 months to build it. So ultimately, that's when my scalability comes in. I don't have 1,000 servers, but I've got quite a few. Some of them are a little bit different to what some people probably use. And then obviously that makes it cost effective, so I can make full value of all my money I put into my research. And then obviously, because I'm using multiple open source technologies, I can share that with other people. I'm quite happy to share that with other people. But those people also help me when I get stuck. I don't have to make sure I've got a support contract with somebody, or they say, well, sorry, I can't support that because you didn't buy that, you bought that instead. We don't operate like that in the community. We try and help each other, we try and support each other, even if we don't know each other that well. You know, and I think that's very important when you're trying to operate research or you're trying to operate education. It should be as open as possible and as flexible as possible. And obviously, the beauty of all of this now is, as I have all these different ideas and I want to try different automation approaches, I can go and test those without destroying the system that I've already built. And maybe I want to build a completely different physical environment and automate it in parallel to the one I've already got. Now I can compare all of the telemetry data. But all of that needs an ecosystem. So ultimately, that ecosystem means that I get a versatile platform. I can focus on my research and my core work, as opposed to trying just to keep that system working. And the beauty of it being open source, like I say, there's a financial side to look at, there's an operational side to look at, but there's also trying to do something on your own can be very difficult, and you can not even think about 7 things that could go and destroy it because it didn't even cross your mind. But if you have the ability to communicate with other people and share that, someone else might come to you and say, well, I did that, or I did something similar and this happened, so you might want to consider this, or go and check your data for this. But if you don't talk to anybody, you don't know that. So as much as people can help you, you can help them, and suddenly it becomes a nice reciprocal vehicle. And you can do it anywhere in the world. It doesn't have to be just because I'm in the UK and I'm in the northwest of England. Everybody can communicate anywhere in the world. You can keep bees anywhere in the world. You can keep fish anywhere in the world. You can even potentially go and keep fish and bees on Mars. But how are you going to monitor it? And how are you going to build an ecosystem that scales if you have to put it on a spaceship and leave a robot to look after it? So maybe sometimes I think a little bit too big, but fundamentally, the vehicle is capable of delivering so much flexibility and scale, whether you want this much scale or this much scale or this much scale, but the principle's the same. And that's what it looks like in the real world. So that there is a highly scalable, fault-tolerant Apache CloudStack cluster. That is the primary management server. That is the secondary management server. That is the primary storage. That is the secondary storage. That can fail over to that. That can fail over to that. And that is a compute node that can, even though it's only got 16 gig of memory on, it can run multiple virtual lightweight machines. And all of this is running KVM and Apache CloudStack. And that over there is an ESP32 with a LoRa antenna on it, and it is capable of communicating secure messages up to 10 kilometers. And these are some of our beehives. You'll notice bees can't get into that one. That's a data center. Has its own battery system with its own battery management system. There's literally a kilowatt of solar panels to the side, which doesn't sound a lot, but all of that running off that power over Ethernet switch to power all of this equipment, and that's actually got 2 terabytes of storage across it, believe it or not, is running in that beehive. The battery system sits there, the compute system sits there. It's all fully waterproof. These are what they call polyhives, so they're insulated. I have a fan system in there that basically uses the ESP32 to make sure none of this stuff doesn't overheat. It also has a heat mat in the bottom to make sure the batteries don't get too cold because they're LiPo batteries, so I have to operate them within certain temperatures. But I've got 3 kilowatts of battery power in there, plus the 1 kilowatt of solar panels that can run this, and I can put this anywhere within about 3 to 4 kilometers. And that's the fish that enable the aquaponics. And those are the sort of things that you can grow in that aquaponics. And I'm monitoring all of those systems using that ecosystem that I just showed you, all because of Apache CloudStack.
Thanks, Mike. Brilliant.
No problem. Thank you.